So here we have numpy imported, which means we can work with uh, vectors and multi-dimensional arrays. So right now we will look at the np dot array. There's something called np in the array. The numpy library is quite comprehensive. So we're going to go through its different features, uh, you know, in each session. So here it says, number one, create 3 vectors over Rn where n is equal to 5. So 5-dimensional vectors. And declare these with v sub 1, v sub 2, v sub 3. So what would v sub 1 look like? It would have v sub 1, and this would be equal to, I'm just going to put any 5 numbers. So I'm going to go 1, 2, 3, 4, 5. Okay. So these are all real numbers. Remember, the set of natural numbers are a subset of the set of real numbers. So these are all, well, that's an example of one vector over Rn. And then v2 could be 7, 8, 9, 10, 7, 8, 9, 10. I'm just going up in increments of 1. No particular reason for me to use these numbers. Just any random number will do. And then we have v3. So 12, 13, 14, 15, 16. There we go. So that's how we create 3 vectors. Then it says for number 2, put the vectors inside the matrix M that is a 3 by 5 matrix. How do we create a matrix that is 3 by 5? So, well, if you want to create a matrix, that's again just a multi-dimensional list in Python. So what I'm just going to do is I'm going to remember a matrix is rows of vectors. A matrix is a rows of vectors. That's one way to look at it. It's either columns of rows, columns of vectors, or rows of vectors. Here we'll go with rows. So this is row number 1, which is a vector. So these are all subsets of the row space of M. Okay, so V2 and then V3. And now we have ourselves a matrix. If I now type in M, there you can see. If you've used MATLAB, the coding approach should be very familiar. Oh, by the way, if you want to work with MATLAB, this course will help you out a great deal. Maybe I'll add snippets for MATLAB. So we won't cover MATLAB in the course, but I'll give you the MATLAB implementation of the Python code that we're doing. MATLAB, of course, stands for Matrix Laboratory, if I remember correctly. Anyway, so now we have a matrix, which is a set of 3 subsets of 3 elements, where each element is itself a vector. So that's element 1, element 2, element 3. How do we turn this thing into an array? We go np.array, and then you plug in your list. I'm going to go ahead and put M in there. Now, of course, I could have made these numpy arrays first and then put them in M, but the order doesn't matter. NumPy will take care of it. So let me add some comments in here. We will declare 3 vectors over R3, and then declare the matrix M, which is 2 by 3. And then here I'm just previewing the matrix, preview the matrix. Okay. Oh, excuse me, 3 by 5. Yes, 3 by 5. Okay, we have 3 rows of elements where each element is a space of 5 components or 5 elements. And then here we are going to convert the matrix M to a numpy multi-dimensional multi-dimensional. Well, that's actually not multi. It's actually a vector. It's actually an array with 3 elements. So um, a numpy array. Now, how do we get the first element of the row space of M? If I want the first row, I'm just going to go M0. It's going to give me the first vector inside the matrix M. Okay? And then exactly, I can use square bracket notation. If I want to add these 3 vectors together for step number 4, so add the elements of the row space. What are the elements of the row space? They are M sub M0, M1, and M2. And here's the thing: in programming, we start our subscripts from 0, so we count from 0. So this would be the first vector, second vector, third vector. And then if you want to add them together, well, we just numpy allows you to add them together like so. And we can call this what should we call this? This will be V sub 4. Remember what we said about the vector space? We said it is addition. The closure axiom applies to it under addition. So if you add 2 vectors together, you get a third vector. That's what closure is. And you will see now, if I add these together and I say V sub 4, that is my mistake. I did convert M to a numpy array, but I did not reassign it. So I'm going to reassign it. Okay, so M is going to go from being a Python list to now being a numpy array. Okay, I was missing this bit. So one more time. Now I'm going to create a 4th vector out of the sum of these vectors. And if I now say V4, there you can see we've done vector addition. And that's the answer.